Hi guys, welcome to C++11. I'm going to do a C++11 series of videos specifying all the C++11 features. So this will be a video regarding the auto keyword. Um, so basically we are going to talk about the auto keyword which has powered C++11 a lot to behave like JavaScript or Python. So before going to auto keyword, I would like to tell you that C++11 features are so interesting and nice that if you start learning C++11 feature, you will be not very upset that oh God, in C++ I need to learn this lot many things. Rather than you will be thinking, oh, these are all the features that I have been looking for in C++ since long time. So C++11 features are really interesting, and uh, if you start learning them, you will be start loving C++ because it makes C++ as smarter and as uh, efficient and easier compared to our modern languages that people are crazy about, like JavaScript, Python, and all those modern languages. So we'll be looking into the auto keyword. Auto keyword basically is built on type inference property of a programming language. Type inference is not something new for a programming language. Type inference is inferring the type, data type, and assigning it to a variable during the compile time. So if you see the type inference property of a programming language, there are two kinds of uh, type type two type of programming language. One is strongly coupled and loosely coupled. So basically strongly coupled languages do not have type inference property inherited in their compilers, but loosely coupled like JavaScript or Python, though or many scripting languages have type inference property inbuilt in their interpreters. But C++11 makes a balance. The language remains type safe. It means strongly type coupled, as well as it introduces a feature of type inference, which is auto keyword. So the video will be revolving around the vector example. So you must be familiar before watching this video. You must be familiar about vector and how to iterate over vector. So just quickly, I am giving you an example of vector and how to iterate it. So basically, when we define a vector we have defined a vector with 6 integers, and we're trying to iterate a vector using a loop. So this is the uh, basically this is the syntax how to initialize an iterator of a vector type and iterate over it. It starts from v dot begin. V is the vector object, and it ends at the v dot end. So when you say when you write the syntax, it looks quite messy and uneasy for a programmer to write each time this much initialization, this much uh, syntax for initializing just a variable. So rather than we just go ahead and write a single keyword auto. So auto will be initializing the variable it to vector kind automatically. So this is called type inference. It is automatically getting the data type and assigning it into it. So the now question is, from where it gets the data type? It is from the initializing expression or object. Here v dot begin is the initializing object, and from here auto takes the data type and it assigns to it. Few more example you can see. With the help of this function, I have defined fun1. So fun1 has two arguments like auto A and auto B. I'm calling fun1 with I'm passing two integer 2 and 5. So auto in the definition, actual in the formal argument, auto A will be treated as integer and B will be treated as also an integer. The second call fun1 4 comma 4.5, where the parameter I'm passing is an integer and a double. So fun1 auto A will be inferred as an integer, and B will be inferred as a double. In this third call, I am passing a character and a string, so A will be inferred as a character variable, whereas B will be inferred as a string. So these are the examples how auto will be used. Now let's quickly run this program and see the outputs. So these are the outputs inside one. For the first output is 2 and 5. For the second call it's 4 and 4.5. For the third call it's A and Madhu. And this one is from this vector iteration, from this for loop. The vector is 1, 2, 3, 4, 5, 6. So output is coming as 1, 2, 3, 4, 5, 6. These are some vector properties I'm using to verify the size of a vector and the capacity of a vector. And I'm resizing the vector, reallocating some 100 memories, and again checking the capacity of a vector. These are all things related to vector. You need to go to STL part to know all these things about vector. Okay, so there are a few points regarding auto I want to tell you that previously when we don't had auto, we used to use type def to rename such big declarations like vector, colon, the iterator, and it. So to substitute such big declaration, we used to use typedef, but now typedef is depreciated. And moreover, I want to make 2 points regarding the auto uses. I'll be deleting all this. Okay, so here a is in constant integer, and refer ref is the reference to a. So now auto a, I'm assigning a. So what will be the type of a? Okay, so the type of a will be integer but not reference. It will be constant integer. Let's give a check. So a is now constant. The type of a is const integer. Okay, so you cannot change the value of a constant. That's the reason it's throwing an error. Okay, the next point is, now I'm making the reference ref as constant. Now what will be the type of a? Yep, it's possible. Now it doesn't throw any error. So now type of the auto a is just integer. Remember, it won't be a reference because you are initializing a from a reference. That doesn't mean that a will behave like a reference. it will behave like an integer, but it won't be constant because constant is a qualifier applied on the reference, not on the base data type. So the next thing I want to make into your notice is that auto is obviously a compiler overload, uh, and it should not be used unless and until it is essential and highly productive. So thanks, and I'll meet you soon.